Here, essay-focused quantum physics Q&A sheet based on the handy physics answer book and other beginner-friendly sources. This is part of my ongoing effort to help you learn about the amazing science that makes our modern world possible. If you want to support this channel and have some extra money lying around, consider donating via the links in the description below. Thanks. Now let's get started with the questions. First up, what is quantum mechanics? Quantum mechanics is the physics of subatomic particles like electrons and photons, which exhibit both wave-like and particle-like behavior. In the quantum realm, things aren't certain. Instead, they are described by probabilities. So that's the gist of it. What's the photoelectric effect? The photoelectric effect is the ejection of electrons from a metal plate when light shines on it. Einstein explained this in 1905 by saying that light comes in discrete packets of energy called quanta or photons, and each photon can eject an electron if its energy exceeds the metal's work function. He was awarded the Nobel Prize in 1921 for this, though it wasn't specifically for quantum mechanics. That was just one piece of the puzzle. Next, we have what is superposition. Superposition is a key quantum phenomenon in which a particle exists in multiple states simultaneously until it's measured. For example, in the famous Schrödinger's cat thought experiment, the cat is both alive and dead until we look and find out otherwise. Mathematically, this is represented by a combination of states. And another related question, what is entanglement? Entanglement happens when two or more particles become linked together in such a way that knowing the state of one instantly tells you the state of the other, no matter how far apart they are. Einstein considered this spooky action at a distance, but it has been experimentally verified and is a fundamental part of quantum mechanics. We also have a question here about the Schrödinger equation. What is it? The Schrödinger equation is a mathematical formula that's central to quantum mechanics. It is a kind of wave equation that takes the current state of a particle and its potential energy to calculate its wave function, which gives the probability of finding the particle in a particular place. However, it doesn't tell us where the particle will be, only where it's likely to be. Next, what's the uncertainty principle? The uncertainty principle, discovered by Werner Heisenberg in 1927, states that you know both the position and momentum of a particle precisely at the same time. The more accurately you measure one, the less you know about the other. Mathematically, it's represented as delta x delta p is greater than or equal to k2, where delta x is the uncertainty in position, p is the uncertainty in momentum, and k is the reduced Planck constant. This isn't a limitation of our measuring devices, it's a fundamental property of nature. Okay, now let's talk about applications. We have a question here. How do quantum computers work? Quantum computers utilize quantum bits or qubits that can be in a superposition of states. This allows them to perform many calculations at once. By exploiting entanglement and other quantum phenomena, quantum computers can perform some tasks much faster than classical computers. And since we're on the topic of quantum computing, here's a related question. What's a quantum bit or qubit? A quantum bit or qubit is the basic unit of information in quantum computing. Unlike a classical bit, which can be either 0 or 1, a qubit can be in a superposition of both states at the same time, allowing for more complex calculations. Qubits can be represented by various physical systems such as the spin state of an electron or the polarization of a photon. Another question we got is, why is quantum physics weird? Quantum physics is often considered weird because its predictions go against everyday experience. For example, particles can tunnel through barriers, be in two places at once, and change when observed. This challenges our classical intuition and raises questions about the nature of reality. Some people call this the measurement problem. Alright, so those were the questions we got. But to better understand them, let's take a quick look at some related concepts and terms. First, what is the wave function? The wave function, denoted by the Greek letter psi. Psi is a mathematical description in quantum mechanics that gives the state of a quantum system. It contains all the information about the system and evolves over time according to the Schrödinger equation. The square of the absolute value of the wave function psi2 gives the probability density of finding a particle at a particular location. Next, what is quantization? Quantization is a process by which energy, momentum, frequency, and other properties of a system can only take on specific discrete values rather than a continuous range of values. This means that these quantities are quantized or come in chunks. For example, the energy of a photon is quantized, which is why it comes in discrete units called quanta or photons. Next, what's the Copenhagen interpretation? The Copenhagen interpretation is one of the most widely accepted interpretations of quantum mechanics. It was developed in the 1920s by physicists like Bohr and Heisenberg. One of its key ideas is that a quantum system doesn't have definite properties until it's measured. Before measurement, it exists in a superposition of possible states, but once measured, it collapses into a definite state. This probabilistic nature of reality is a significant aspect of quantum mechanics. Okay, so those are some of the key concepts and terms related to quantum physics. Hopefully this helps you better understand some of the basics. And remember, if you're curious about any concept in more depth, or want to explore advanced topics in quantum physics like field theory, Bell's theorem, decoherence, or anything else, science and math related, just ask away. This entire Q&A sheet series is designed to give you just enough information to satisfy your curiosity and point you in the direction of further learning. You can always ask follow-up questions too. No question is too simple or too complex. For instance, someone asked me the other day, I keep hearing about gravitational waves but don't really understand the concept. Can you explain it to me? And I made this video as a result. So feel free to ask away. I'll continue asking people questions, compiling the most interesting ones, and creating videos like this one to share what I learned. If you found this video helpful, please hit the like button and consider subscribing to see more like it. And if you have a friend who might enjoy this type of content, feel free to share. As Albert Einstein once said, any fool can know the rule. To be a master, you must know the exceptions. While that might not be directly related to quantum physics, it speaks to the idea that understanding the unexpected and counterintuitive aspects of a subject is key to mastering it. Quantum physics certainly does that. If you have a question that didn't make it into this sheet, either check out my other videos or ask away again. There's a lot more to cover. Thanks for watching and keep on thinking.